All right, what we're going to do in this semester, okay, I will try to focus on one topic each time and to go over the material and we try to, but you still probably get some homework from previous math counts, but we're trying to go a little bit deep level, okay, high level, okay. I also look at the AMC 8. I find out majority of problems in AMC 8 are simpler than math counts, okay. Math counts can be very difficult, some problems. If you look at the state nationwide math competition. So it depends, maybe next time you will get a homework assignment that will be a little bit difficult than the previous. Most time in the last fourth semester, I gave you the chapter 1 problem. Okay. Okay, so what are we going to do today? We're going to focus on sequences. Okay, I have some problems to discuss today, and I hope you are able to solve. Okay, maybe one problem we discussed before, but let's try. Okay, so my first problem is I'll give you a pattern. So let's begin with this first. Okay. Yeah, this is about sequences. So we have 1, 7, 25, 61, 121. Okay, so the question is, what is the next term? Okay. And maybe you can find the general term. Okay, so this is not only just next term, maybe we can get a general formula. Trying to figure out the general formula. Okay, when you're given sequences like that, it's very typical. Even math, even SAT, okay, you have also several answers that ask you to put details. Okay, so the most natural method is just take the difference. Okay, the most natural method is take the difference. So 7 minus 1, 6. Okay, right? And then 25 minus 7 is 18. 61 minus 25 is 36. 121 minus 61 is going to be 40. It's going to be 60. Yeah, 60. So this is another sequence you can get, right? Right? So 6, 18, 36, and 60, they are all divisible by 6. That's my hint. Okay, so you can write as 6 times 1, 6 times 3, 6 times 6, 6 times 10. Okay, if you have a sequence, it's multiple of some numbers, right? It's multiple of some numbers, then if it's multiple of some number, you divide it, you have to get rid of the factor first. So make it easier to look at. Okay. Huh? 211. Yeah, 211. So now from 1 to 3, right? You add 2. From 3 to 6, you add 3. And from this, you add 4. Right? So actually, what we got here, you have to look at the third sequence. You take a difference, 3 minus 1, 3, 6 minus 3, and 10 minus 6. So get 4. So the next one will be 6 times 15. Okay, 6 times 15. So some number minus 121 is going to be is going to be 121. X minus 121 is going to be 6 times. Okay, so that's why, you know, X is going to be 121 plus 6 times 15, and that is what, 221. Now my question is, are you able to get a general formula? Yeah, try to get a general formula, the nth, yeah, the nth term formula. So when you do that, you look at, so A2 minus A1 equals 6 plus 1, right? And A3 minus A2, 6 times 3. A4 minus A3, 6 times 6. So what you have to do is you have to find out the formula for the 1, 3, 6, okay, and the 10, right? Okay. So you have to figure it out. You have to figure out this sequence. Okay, how to express this sequence, the general term. Okay, right? Okay. How to figure out this sequence? Okay, so you can, yeah, it's this sequence. This sequence increased by it is increased by 2 by 3. See, it can also, let's do this again. Let's figure it out. So we come back to this problem. Given the sequence 1, 3, 6, 10, 15, okay, find the general formula first. Find the nth term. Okay, find the nth term. Okay, so you can get 100. Yeah.
N times n plus 1 over 2.
Okay. Yeah. So let's do this problem. Maybe you come back to figure out that, right? Just add them together. All right. So we got, okay, let's use a B1, right? B2 minus B1 is going to be 3 minus 2. Okay. What is that? Okay. Okay. It's increased. Yeah, B3 minus B2 is going to be 3. B4 minus B3 is going to be 4. Okay, so that is easy to figure out, right? And then Bn minus Bn minus 1, and as you can see that, it's going to be n, right? Yeah. So you add them together. Okay, you add them together, you find out all the terms in the middle will be canceled out. And you get 2 plus 3 all the way to n. Now one term is missing. B1 is actually the 1, right? So n is going to be 1 plus 2 plus 3 all the way to n. Okay? So this is going to be n plus 1 divided by 2. So the nth term is just n times n plus 1 divided by 2. Okay? Someone's online? Okay, good. Alex, muted. Okay. Right. Okay. So we go back to the above problem. We go back to the above problem, right? It's A2 minus A1 is going to be it is going to be 6, right? 6 times 1. A3 minus A2 is 6 times 3, right? A4 minus A3 is 6 times 6, and keep going. So that's the third term. Okay, that is the third term. So in general, an minus 1, 6 times the n minus 1th term. Okay, the n minus 1th term is going to be yeah, something like that. So if you add them together, you have to deal with another formula. Okay, so what you got here is, yeah, this is going to be 6 times 1 times 2 divided by 2. Okay, that's 6 times 2 times 3 divided by 2. Here's 6 times 3 times 4 divided by 2. Okay, so when you add them together, you get an minus a1. A1 is still 1, but this time you get those many numbers. Okay, so the question is, how do you add those numbers together? That's a good question. Okay, so A1 is 1, right? We already know that A1 is 1. A1, yeah, A1 is 1. So don't worry about it. A1 is 1. Okay, so the general formula AN is going to be 1 plus 6. I'm not going to go back to this problem. I want to do the separate problem. Okay, you see, so this is the answer. As long as you are able to add all the numbers together, you can do this. All right, so I'm going to recall a couple formulas. Okay, 1 plus 2 plus 3 all the way to n is going to be n times n plus 1. Everybody knows that. But how about 1 square plus 2 square plus 3 square? Okay, it's going to be n times n plus 1, 2n plus 1 divided by 6, which is discovered by mathematicians. Okay, and 1 cube plus 2 cube plus 3 cube all the way to n cube is going to be n times n plus 1 divided by 2 n square. It's surprise to me is these two formulas, and it's always the square of the sum of n plus. You see, right? So in other words, this is going to be 1 plus 2 plus 3 all the way to n squared. Okay, we should know those three formulas. Okay, you should know this. We can double check. We can double check why this is true. You see, look at the 1 cube plus 2 cube, always perfect square. It's 1 plus 8. 8 is 9. 9 is 3 square, right? Good. And the 1 cube plus 2 cube plus 3 cube is going to be 9 plus 27, 36. It's going to be 6 square. It's the magic, right? So it's always perfect square coming from the sum of the cubes of those numbers. Okay. All right. My good exercise is here. Simplify the expression m 1 times 2 plus 2 times 3 plus 3 times 4 all the way to n minus 1 times n. Okay, if you're able to do that, you can go back to this. Remember, right? So I'm not going to, yeah. Okay, so one by one, they're all connected. Okay, look at this problem. Okay, express as one simple expression. So Eric, do you have answer?
Two times n times minus 1 over 2. Actually, n times n minus 1.
Okay. Actually, what we're going to do is, okay, you look at the general term. Okay, the general term is ak, right? Is going to be k minus 1 times k. So actually it's going to be k squared minus k. So every term it can be separate. So it's going to be 2 squared. You see, it's going to be 2 squared minus 1 squared. That's first term. Plus 3 squared minus 2 squared. Okay? Not 3 squared. 2 minus. Not square. Okay? I'm confused there. Let's see what I'm talking about. So it's going to be 2. Okay? So every term looks like that. It's a 4 squared minus 4. And so on. It's a, last term is n squared minus n. Okay? If you express in that form, then you can, yeah, you can solve, yeah, you can regroup them, right? It's going to be 2 squared plus 3 squared all the way to n squared. And minus 2 minus 3 plus, right? Here's n. Okay? So I can add one to both. So it's going to be 1 squared plus 2 squared all the way to n squared minus 1 plus 2 plus 3. It does not change the value. Finally, right? Apply the formula. Okay? But that's you can still simplify. Its common fact is n times n plus 1 divided by, let's say, divided by 2. If you take this out, and here's 3, and minus 1. And combine them. And I get 2n minus 2n plus 1 minus 3. Okay? And you can continue simplify. It's 2n plus n minus 2. So n minus 1. And 2 cancel out. A surprise to me is n plus 1, n minus 1. It's a product of 3 consecutive numbers. Okay? It's always a product of 3 consecutive numbers. You can express in the form like that. All right. So you double check. You know, when you sometimes you get an answer, make sure maybe it's not correct, right? So it's 1 times 2, 2 times 3, and what is the n? As the last time, n is supposed to be 3, right? N is 3. So anyway, first of all, this is going to be 8, right? But the n is 3, so this can be 3 minus 1 times 3 plus 1 divided by 3. Cancel it out. And that's 8, right? That's correct. So it's perfect. So you can even discover some interesting new formulas, right? So you get the product of 3 consecutive numbers. Always. Yeah. Okay. It's 1 times 2. Yeah, let me record this. 1 times 2, 2 times 3, and 3 times 4, all the way to n minus 1 times n is going to be n minus 1 times n plus 1 divided by 3. Okay. I did not know that until this last minute. Okay, I just derived that. It's interesting, though, when you do this. Okay. All right. Yeah, there's we did this problem before, but I'm trying to solve it in more scientific. But sometimes you're not that's lucky enough to figure it out. Okay, so we have the following problem: the term x and x plus 2, x plus 4, and x plus 2n form a symmetric sequence. Okay, was x an integer? X is an integer. Okay, if each term of the sequence is cubic, the sum of the cubits is negative 1,107. So what is the value of x if n is greater than 3? Okay, so if it's cubic, the integer not necessarily to be positive integer, it's going to be negative, right? So clearly, okay, so what is n if n is greater than 3? Okay, all right, so, well, by trying, there's some shortcut, genius way to solve this problem. Okay, some student can see the numbers and quickly figure it out. Okay, quickly figured out the answers. For example, probably you don't know that. Okay, here's a hint, right? Hint is 5 cubed plus 7 cubed plus 9 cubed is 197. If you knew that, you probably can solve the problem quickly. Okay, and but if you haven't, how do I know that, right? Right. So assuming we don't know this. Okay. Yes. Yeah, first of all, you try this. You see, I give you this. Can you figure out the end first? I give you this hint. You do a shortcut. I'm going to show you more standard way. Suppose this is a research problem, and you have to figure out the end, right? Okay. I did not solve the problem using this shortcut because I did not know that is, 5 cubed plus 7 cubed plus 9 cubed equals 1,107. I just did it directly, okay, using the form. I think the math problems are more challenges than the MSc 8. Have you tried the MSc 8? Yeah. Ryan, did you solve the problem? Can you sit to the front? Don't sit next to him. Yeah. Your name is recorded here. I don't want to call your name again. Okay. Okay. So the most standard way, that's no trick, is you try to, add them together. Okay. Then I did. Okay. And how can I add them together? This is not increased by 2 each time, right? So what they do is you expand it, and this is x cubed plus 3 times x squared times 2, and 3 times x times 2 squared plus 2 cubed, and so on. Okay, the last term is x cubed plus 3 times x cubed, x squared 2n, then 3x 2n squared plus 2n cubed. Okay, I add them together. I look at all the n cubes, right? How many there? It's actually is n plus 1 n cubes. Then apply the formula for above formula for each of them. You group them together, right? So you get x cubed, and so on, x cubed. It depends on how many. Then you also get you get x squares, right? And you have a 3 here, 3x squared. And each term you get 2 plus 4 plus plus 2n. Okay, and the last one is cubed. Okay, plus 3x 2 square 4 square all the way to 2n square, and then the very last. Right. So add together, you can do that. Apply all the formulas we mentioned. I find out. Yeah, let me copy this. I find out I have a x times. Yeah, I have a x plus 1, x n plus 1, n plus x, and then you can factor this out. 2n squared plus 2n plus 2nx plus x squared. Okay, so then what? Then it's supposed to be 1,197. But that actually is good because left-hand side is the product of 3 terms. So right-hand side is just integer. So this integer should be factored out. So you look at, how do you quickly factor the number? You look at whether it's divided by 3, right? You find out it's divided by 9, okay? You add those 3 digits together, 1 plus 1 plus 9 plus 7 is going to be 18. 18 is divided by 9. So you divide by 9, then you later on you can figure it out it's also divided by 7, and so on. And this is what you can get. It's going to be 719. So you have a product of that, and then you can try possible solutions, and then you get what is possible n plus 1. N plus 1 could be 3, could be plus minus, could be 7, could be, okay. So it's easy then to figure out the possible solution. So later on, you will figure out n is going to be 6, and x is going to be 9 and -9. Okay, you can quickly get that. Okay, n is 6. Okay, n is 6. N plus 1 is 7. Okay, and x is going to be negative. Yeah, -9. Then that works. So from here, it'll be much easier to figure out. Okay, so I tried several possible solutions. N plus 1 is going to be 7. That works. Okay, so you get n immediately. Then you determine the x is actually going to be -9, not the not the n plus x is not necessary to be x equals 2 does not work. Then you get a negative sign. Then the other terms you're going to give. That's the solution. There are not many choices for n anyway. N plus 1 should be one of those factors, but only n plus 1 equals 7 works. Okay, so that is a standard way to solve. It takes a little bit more time, but some students can finish that within 3 minutes. Okay, but if you know this identity, then it works. And how does the people get this identity? This is because they do the calculation, because it's it's x cubed plus you can assume the simplest cases begin with 1 and 3 and 5, right? but then you don't get this number. So yeah, 1 cube plus 3 cube plus 5 cube, you get, yeah, here's one, yeah, I'm not going to get too many terms. Just do some exercise. You can figure it out. It's going to be 28, so it's much smaller than the number you want. So 1 cube plus 3 cube plus 5 cube, and using calculate, and you get 153. So that's still small number. Then that's most of students do, right? It's going to be either 7 cube. So 7 cube, I have to calculate 496. It's still smaller than the number I want. It's 1,197. So just one more. And you get 1,225. Then you say, okay, this is larger than what I need. Okay, it's larger than what I need. And you just sit there. You look at all those numbers, you're stuck there, because there's no way you can get it, right? But you don't know which one you should start. You always start from 1. Okay, but if you look at those numbers, you sit there for a while, you find out this number is going to be 1,197 plus 28. Then you all of a sudden you figured out that the sum is going to be 1197. Then next step would be easy. If you know this, okay? If you know this, and then it'll be much simpler, okay? So because yeah, if you get that part, okay, it's not easy. How do you know, right? Even some students get the fourth step, right? Fourth equation, probably cannot recognize 1,097 plus 28 just equal to 1,225. Okay, but if you get that part, then what we should know, right? X cubed plus, right? Then, but you want to get negative, right? So that's fine. Now negative 5 cubed plus negative 7 cubed and plus negative 9 cubed is going to be negative 1,000. Then you know how to get the X in. Okay, right? So I remember, yeah, n cubed plus, yeah, you only have 3 terms. Okay. Yeah. Then you can, from here you can solve, find the solutions. Right, but this is still not enough. You cannot just say, hey, here's x cubed plus x plus 2 cubed and x plus 3 cubed. It does not work, okay? Because there's no n here, right? It's going to be n plus 4, okay? So you can say n equals 3, and what is x, right? You still cannot solve it. That's a trick, right? Yeah, n plus 4 should be negative 5, right? Yeah. So you can get an x, but x, what you get is n3. Look at that. I already assumed that n is greater than 3. Okay. If you do this way, you're not, n is how many n here, right? N is going to be less than 3, less than equal to 3. So that you only have 3 terms. It's not working, okay, like this. So yes, from here you get 1197. That's a special solution, right? X plus 4 equals, what is the smallest number? Okay, actually it's going to be negative 5. Okay, and after the 2, sorry, negative 9. Yeah, negative 5 is the largest number. X is negative 9. Okay, x is negative 9, but in this case, n is smaller than 3. Okay, n is smaller than 3. Okay, it's not working. So you have to add more terms, but that's okay. Add more terms. going this way. It's -3 cube, -1 cube, plus 1 cube, plus 3 cube, plus, yeah, 3 cube. Yeah, that's it. Then still this is going to be in the 197. Then from here, you can figure out, the n. You increase the n, okay? X is still -9, but the n is larger than 3, okay? Here the n is going to be 2. Yeah, n is 2, right? Yeah, for 9 plus 4, n is 2 in this case, n equals 2, but that's smaller than 2. Okay, so it's not yeah, it's not good. So here n is going to be 6. X is still equal to -9. So there's another trick here. Okay, but the most difficult part is the first one. How do you recognize 5 cube plus 7 cube and plus 9 cube equal? So I did not do this way. I learned from somewhere doing this, but actually what I did is I just show you my way. It's a little bit more stupid, but I that's pretty standard. I add them together, and I'm very, very lucky I can factor it. Okay, so then I factor 1,197, then you solve the problem. Okay, anyway, for one particular problem, there are several ways to solve it, and some are more standard, some are shortcut, and depends on who can, figure it out. Okay. So I want to spend a few minutes about the geometric series. Why it's called a geometric series? Because it's coming from geometry. Okay. So first of all, yeah, the first term is a times r. Second term is a times r squared. Now I just a. Okay. I don't want bigger one. It's a and the r squared. No square. No square. Just r. Okay. And so on. The nth term is a r to the n minus 1. So this is called the geometric series. Series means you have infinite terms. What we needed to know is a couple factors. Yeah. So the sum the sum of those terms is going to be 1 minus Rn over 1 minus R. Now, do you remember how to get this formula? Yeah. Yeah. Okay. Okay. Now, so we have to talk about the concept limit. Yeah, the limit concept, it's the first topic in calculus. But we also should know that. Okay, let's take a look at n equals 0.1. Okay, and the n squared is 0.01. N cube equals 0.001. Right? And keep it going. N to the n minus 1, right? It's 0.00. Okay, how many terms? You have n minus 1 terms here. So it's getting smaller and smaller. It approaches 0. So in mathematics, in this case, we simply write, okay? We simply write this notation. This is called the limit of r to the n is going to be 0. Okay? That's called the limit case. It's 0. Okay. So it approaches 0. It can never be 0, but it approaches 0. That's the concept of the limit. Okay. So, and this is true for any number r with absolute value r is less than 1. Okay. So as long as it's a number smaller than 1, when you increase the power, as this is just getting smaller and smaller, and approaches 0. Okay, but above is just easy to understand. It's a 0.1 is smaller than 1. When you multiply, square and cubic and just getting smaller and smaller. Okay, so if you apply this idea to the above problem, and you get infinite many terms, not just stop at n, or n could be 1 million, 1 billion, but suppose, and this is going to be just 1 over 1 minus r. Why? Because in this case, yeah, for r absolutely less than r, and we have this identity holds because you look at the above. Okay, here left hand side you have n terms, right hand side you have fraction. But suppose n is getting close to infinity. Okay, so you have an infinite many terms on the left hand side, and the right side just only one fraction, but that fraction approaches 1 over 1 minus r because r to the n can be ignored almost. Okay, so you have this identity. So this is in the sense of the limit. Okay, okay, in the sense of a limit. Okay, yeah, this is the only place we needed to understand the limit concept. Okay, it's 1 over r. Okay, so let's take a look at the next problem we discussed before. Let me repeat again. So 0.9 bar. That's a typical problem. 0.9 bar is going to be 0.999, right? According to this notation. You have infinite many nines, digit 9. Now we can have a better understanding of this. So that means it's going to be 0.9 plus 0.09 plus 0.009 and 0.009, right? Keep it going. So this can be viewed as the sum of the infinite many terms. But each term right now, it's going to be 9 over 10. 9 over 10 squared, 9 over 10 cubed, 9 over 10 to the 4th power. Okay, so can I find the sum using the above formula? I can. I can take 9 over 10 out. Each term you get 1 over 10, 1 over 10 squared, 1 over 10 cubed. And here r is 1 over 10. Okay, so according to the above formula, it's going to be 1 over 1 minus 1 over 10. This is the equality. Okay, we are talking about the limit sense. Okay, then you get 9 over 10. Here, 9 over 10. So cancel it out. It's just equal to 1. So the limit case is 1. So in mathematics, 0.9 bar is just equal 1. It's the same. Okay. Right. So my next question is, I'm trying to make. I have an equilateral triangle. Okay. I divide them into this. I try to shadow one of them. Okay, so let me pick up. Yeah, let them pick up the middle one. Okay. This is a little bit. Then I divide this into 3 equal triangles. Then I pick up this, the middle one. Okay. Then I try this. Then I try this. Then I try this. All right. So we trying to figure it out. This is here's a equals 1, okay? A equals 1, a equals 1. We're trying to find the total area of the shaded triangles. Okay. Okay. So the sum should be much smaller than the larger one. Okay. Okay. I know the area of the equilateral triangle. That's the formula, right? If we have A, the area is going to be square root 3 over 4A squared. Okay. So we have to label them. You know, this will be A1, that will be A2, A3, right? So what is the edge length of A1? I probably have to just figure out A1, A2, A3, right? I think it just divide by 2. Do you agree? Right? Because this equilateral triangle, the edge side, one side divided by 2, you know, the middle point, right? This is the middle point. So A1 is just 1/2, okay, right? A2 is again 1/2 and a half, right? So it's going to be 1/2 squared. A3 is going to be one half of A2, right? Just getting smaller. It's 1/2 of cube. And to keep it going, AN is going to be 1/2 of to the power n. So that is the edge length. Can you find the area and add them together? Try this.
Root 3 over 12.
Hmm?
Root 3 over 12.
That's 3 over 12. All right. So let's figure out that area. Area is going to be 1/2. Anyway, we have the same common. Sorry for that. Okay. Sorry for that. Let's disappear the screen. I don't know. Okay. So area, let's look at the AK. AN, the nth term. That's right. AN. AN is going to be square root 3 over 4 times AN square, right? And then square root 3 over 4 and 1/2 to the 2n. Okay. Yeah, because n square, n is already the nth power. So what you can what you get is it's 1/4 to the nth power, because I still needed to write it in this form, sum I. Okay. So now add them together. First one plus second one plus third. Keep it going, right? So every term there's a root 3 over 4. Okay. So it's 1/2, right? And plus 1/4 square. And the nth term, n. All right. I needed to take some common factor out. What common factor out I'm going to take? It's square root of 4 times quarter. Okay, then you have a 1, begin with 1, because then I can use the formula. And the quarter square. And here a quarter of to the n minus power. Right? Then I'm applying the formula. This is 16. So 1 over 1 minus 1 over. Okay, so it's square 3 over 16, and this is a 3 over 4, and let's simplify it. That's going to be square 3, 16, 4 over 3, cancel, and square 3 over 12. Yeah, so that is the answer. Right? So you will see some problems like that, but this is the only place you use the concept and limit. Okay, if infinite terms. Okay, another place maybe you want to the concept of limit is it's like that. Find the sum of you have infinite many terms. Okay, you're still able to find some because if first of all, if I have n minus 1 times n, you stop there, you can get a sum, right? Do you still remember how to get a sum? What you do is you separate this each term. Okay. Then you remove the parenthesis. Once you remove the parenthesis, those two will cancel, those two will be canceled. All the terms in the middle cancel up. It's 1 over 1 minus n. So in other words, this the sum of this so many terms. N could be 1 billion, 1 million. It's always less than 1 because this is always less than 1. But it's getting close to 1, right? When n increases. So that's another concept limit. So I stop here, but I just talking about this. So in advanced mathematics, we will say that the sum of the infinite terms just equal to 1. So 1 can be expressed as many. Pi can also express as infinite, the sum of infinite terms. Okay. All right. So let's switch to next problem. Okay. I have a sequence. This sequence is generated by a numerical sequence is generated by the following integer. Okay, it's n equals negative n, negative 1 times n, 3n minus 1. Okay, n is integer. The first term, when n equals negative 1, you get a negative 2. Okay, my question is, what is the sum of the first? What is the sum of the first 100 terms? Okay, are you done? Yes. 294. Nope. Okay.
Negative 150.
Hmm?
Negative 150.
Negative 150. Right? Alex, are you working on the problem?
Sorry, positive 150.
Yeah. Okay. All right, so let's take a look. Okay. So let's see. A1, right? Plus A2, A3, all the A to the 100. We probably have to separate them right now. A and it could be negative n, 3n minus negative n. Okay. So when we add them together, we will get negative 1, 3 times 1, right? And I separate the minus negative 1 to the 1. And the negative 1 square 3 to 2 minus negative 1 square. And keep it going. And this is a square, right? So here's the n. 3 to the n. It's a general term. Okay? So if it's 100, then it's 100. 100 minus negative 1 to the 100. So regroup that. You will get negative, and not negative, but the common fact here is going to be 3, right? So you get 3. So what you get here is negative 1, 1, and negative 1 square 2, and keep it going. The last one is negative 1 to the 100 times 100. Now, here is going to be, it's alternate, right? Negative 1 plus 1, negative 1 plus 1, da, da, da. Negative 1 plus 1. So this is immediately equal to 0 because it's alternate, okay? So, but here, it's not alternating, but you still have to, you group those two a pair by pair, right? So every time you get 1, every time you get the 1, okay? So you get negative 1 plus 2, negative 3 plus 4, and negative 99 plus 100. Okay, so you get 1 plus 1 plus 1 all the way to 1. How many terms? 50. So 3 times 50, you get 150. Okay, that's okay. Okay, now the next one is a little bit, it's similar but a little bit difficult. I have the sequence. Okay, the nth term is generated by the following: n minus 1 plus minus n minus 2. N is greater than 2. Okay, so you can get, once the first two terms are fixed, and you can get the third term, fourth term, and the fifth term. Okay, what I want to do is to find the sum of the first, how many terms I'm going to get. Yeah, it doesn't matter in the first 100 term, okay? So let's see. Find the, I have to give you the first two terms, right? So find the sum of the first 100 terms if A1, I just randomly give you a number, A1 is 2, A3 equals 5, for example. Okay, doesn't matter. Okay. This is, so my suggestion is you don't put a specific numbers, otherwise confused. Maybe just put A and the B there. Okay. My suggestion is let A1 is A, A2 is B. Then later on, maybe you put a number there. Let's make it easy. Okay. Otherwise, it's sometimes you will get lost if you only look at those numbers. Right. This is an interesting problem. All right. Okay. Okay. Yeah, let me start a little. Okay, I want to get A3. A3 is B minus A. A4 is A3 minus A2. Wait a minute. A3 is A2 minus A1. A4 is A3 minus A2. So it's B minus A minus B. So it's negative. Not too bad. A5 is going to be A4 minus A3. So A4 is negative A. A3 is B minus A, negative B. Not too bad. It's not getting worse. But I try to find the pattern. So negative minus 4. So I get negative plus A. So which is negative A, negative B minus A. Okay, it's getting close, right? Look at this too. Okay, then A7, do I get the same? A6 minus A5. negative b minus a minus a5. Where's a5? Negative b. Aha, I get a, which is a1. Okay, a8, a7 minus a6, a minus a6. 6 is minus negative b plus 8. So it's b. That's a2. So after that, this is a periodic sequence. Because then a9, it's the same as a3 because you just treat the difference of the previous two terms. Yes. Maybe. I don't know the answer. Okay. So it's a periodic function. So this is a group of 6. Okay. But I needed to look at the sum of this. Okay. A4, A5, A6, which is A plus B, plus B minus A, minus A minus B minus B minus A. This must be 0. All right, you add all those together, it must be 0. That's a periodical. Every group of 6 numbers in the sequence, it's going to be 0. Okay, so it's going to be 0. So now 100, right? If 100, if you divide by 100 divided by 6, right? It's going to be 1, 4, 1, 6, 40, 16. That's 36. So remaining is 4. So 100 is 6 times 16 plus 4. Right? Yeah. So if you list the 100 terms, what you get? You get A1, A2, A6. That's one group, and keep it going. And the last group is only partial. And last 100, A99, A98, A97. It's only partial. Okay, only contains 4 more numbers. So the first number is A, the second number is B, the third number is A plus B, and the fourth one is negative A. No, A minus, B minus, sorry, B minus A. B minus A. Then A4 is negative A. Okay, so the sum of those numbers is only going to be the sum of those, because the rest of them is 0 plus 0, all those 16 groups. You get 16 zeros. And plus A plus B plus B minus A minus A. So AA canceled out. Actually, it's going to be 2B minus A. Okay? So if you are given the value for A and B, then you have the answers. So if A is what I give to you, A is 2, B is 5. Yeah, I'm sorry, this is 7. A is 2, B is 5. B is 5, A is 2, so it's gonna be 8. Okay, so you need to find out the pattern. You know, yeah, it's very similar to the above one, but you have to get the pattern first. Then 100 is going to be 16 groups of 6 numbers plus 4. All right, so my next question is, all right, n is going to be given by 2n minus 1 plus x. Right. So that is a general, okay? So we are given the information, the 6 terms, is going to be 56. Okay, and the ninth terms is going to be 140. Okay, find the x. And the first one, determine the x, right? Second, are you able to find the sum of 100 terms? Or find the ends? Yeah. And then that's the first question. Second question, find the formula an. Okay, not defined by this general formula. Okay, without, yeah, expressed without x, you know. Just, yeah, express in terms of n only. No as no. Okay, if that is the case, I needed to give you the first number. Yeah, A1. Okay, express, find. Yeah, if A1 equals 1. Okay, make it easy. Okay, but for the x, I probably don't need to tell you the first numbers. Okay. No, I don't need to give you because I already told you A6. That's is enough. Okay, so A1 is I cannot change the value of A1. A1 is uniquely determined. Okay. All right. Can you figure that x? All right. So we let's see. How do you solve this problem, right? So you begin with A6. So A7 is going to be A2A6 plus X, right? Okay, I don't need to put the number right now. A8 is 2, A7, and plus X. So it's going to be 2 square A6 plus 2 and 2X plus X. I don't want to add them together. I just keep those numbers because I want to see a pattern later on. A9 is going to be twice of this plus X. So what you get is 2 cubed 8 to the 6, and then multiply this out will be 2 square plus 2, and another one coming from the X. So that is A9. So if you know 8 to A6, so 2 cubed 56, that's easy to get, right? And X, that should be 140. So from here you solve for X. Okay, if you solve for X, you can get, quickly can get x is going to be negative 44. Okay, it's a linear equation. From here, you can see the pattern already. Okay, I keep the x. I'm not going to replace it by a specific number. So a to the 10th is going to be twice, or 2 to the 4th, a to the 6th, and 2 cubed plus 2 squared plus 2 plus 1 and x. Okay, just keep it going. The difference is 6. So an, okay, is supposed to be 2 to the 10 minus 4 is 6. So n minus 6, a to the 6. And here, 2 to the n minus 4. Okay, so here n must be greater than equal to 7, sorry, minus 7. So it must be greater than equal to 7, because otherwise this is not true, right? So this is that. So we get the general formula, but you have to add them together. Remember the geometric formula for this, right? Right? So this is going to be 2 to the n minus 6, a to the 6 plus 1 minus 2, right? Or you can write the 2 first. That's fine. Let's reverse the order because 2 is larger than 1. It's better to write this form. So 2 minus 1, 2 to the n minus 7 plus 1 is minus 6. Okay. So let's simplify a little bit. Okay. So even get a common factor. Okay. Right? And then 2 to the n minus 6. What is a? A is a 56. And what is x? 44. We already find out 44. So you take this, what you got here is going to be 12. Okay. 12 is 3 times 4, so it's going to be 3 times 2 to the n minus 2. So we even get the general formula. Okay. So and when n is 6, wait a minute. Okay. Do I get it? Just a second. Okay. So when n is 6, yeah, this is formula is for n greater than equal to 7. Okay, greater than equal to 7. You cannot say n equals 6. Okay, 12 is 3 times 2 squared, so that's why you get n minus. Okay, so we begin with this. This is n greater than. So when n is 7, when n equals 7, yeah, that's what you get. Okay. That's all. We finished today's class. We focus on sequences. So I try to change the style. Each time I focus on one. Okay. But I do. I still give you. I think I'm still giving you the math counts problems. This is a little bit more challenging than the MSc. But occasionally, maybe I give you this MSc 8.